Okay, Algebra 2, we are getting ready for our third assessment on data analysis. So this is the review that's in your book and in your package. So I just want to work through it. Problem number 1 talks about a volcano in Nicaragua that's part of a ring of fire volcanoes, blah, 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 not related to the answers of the math, but information about the volcano. 60 years worth of eruption data, so you see the table that is there. So first question, what are the average of all eruptions? So what I've already done, I've already entered a spreadsheet with the years and the ash eruptions. And so now I just answer the questions. What's the average of all the eruptions over time? So this is one variable. Those are one variable statistics. So how do I get one variable statistics? Well, I would do that on my calculator, control document. I will add a calculator and I'm just going to say menu statistics, stack calculations, one variable statistics. I've got one list, and that list is the ash eruptions, okay? So if I look at that, it tells me, let me sort of, I have to make this calculator a little bit smaller. Sorry about that. So the average, so the average is X bar. So if I look over here and see, sorry about that, I'm having to navigate a couple of screens here. So if I look at X bar 0.117, so that tells me 0.117 is the average, and that is in cubic centimeter, cubic kilometers of ash. So that's the average 0.117. What is the median? So if I look over on my stat calculations, I find that the median is 0.115. So my median is 0.115. So I'll write that down. What is the total volume of eruptions? So the total volume of eruptions, if I look on my calculator page, that is right here, the sum of all values, 1.291. So that is 1.291 cubic kilometers, okay? What is the standard deviation? Standard deviation is that sigma x. So it's the value that you see, not the first one, but this one. Sigma x, 0.028079, 0.028079 is the standard deviation. And now the value of R, what I really should have asked is those questions are out of order. Let me ask the line of best fit first. So the line of best fit. To find the line of best fit, I've moved beyond one variable statistics into two variable statistics. So I have to think about it. What's the independent variable here? Well, it should be, in this case, I should have, my time and then my volume of eruptions. So time should be the x-axis and vertical should be the volume of eruptions. So to find that line of best fit, I can stay there in my calculator page. Two ways of doing it. If I stay in the calculator page, I can do menu, statistics, stat calculations, linear regression. So my x variable would be the year, and my y variable would be the amount of ash. And so when I look at that, that gives me the line. So that tells me that the equation of the line is y equals 0.001 856x minus 3.54 214. So that's the equation of my line. The coefficient is 0.934, so 0.934921. Okay. The other way I could have done that, I could have gotten certainly the equation of the line from a plot. So what I could have done in that case, I could have come to my calculator and I could have said, let's create data and statistics, let's put my year on the horizontal axis. Let's put my ash on the vertical axis, and then menu, analyze, regression, mx plus b, and you should see that same line there. Sorry. Okay. So y is equal to 0.001856 minus 3.54214. Okay. And then what does the slope of the line tell us? So the slope of the line, remember the slope is change in y over change in x. So y is the amount of eruptions, x is the year. So the slope of this line sorry. So the slope of this line is 0.01856. So it tells us that the amount of ash increases 0.001856 cubic kilometers per year. What's the expected volume of ash in 2018? In that case, I'm just going to solve for y. Y is 0.001856. I'll substitute 2018 minus 3.54214. So on my calculator, and I'll just simply enter all of that in. So I've got 0.001856. So .001856 times 2018 equals, and then take that number and subtract 3.54214. 3.54214 equal, and that is 0.203268. So 0.203268. So that's the amount of eruptions I expect in 2018. Okay. When will the amount of ash exceed 0.207? So let's first start, when will it equal 2.07? So here I'm just solving for x. So solving that equation for x, so that is going to be, if I come over to my calculator, 0.207, and then add 3.54214, 3.54214 equals, so take that number and divide it by 0.001856 equal, and that's 2020.01. So we should exceed 0.207 cubic kilometers in the year 2020. Okay, that should be it for the first problem in the review. Let me just double check real quick and see if that's it. That is it.